Welcome to the world of logic and computation, a subfield of the theory of computation. In this video, we will be covering the fundamental concepts of first-order logic. Next, we will look at decidability, a key concept in determining whether problems can be solved algorithmically. Finally, we will touch on computational logic and its applications in computer science. So, what exactly is logic? Logic is the systematic study of the principles of valid inference and correct reasoning. Here are the key aspects of logic. First, it involves formal systems of reasoning. Second, it provides mathematical foundations for computer science. And third, it deals with concepts like truth and validity in arguments. Now, let's compare propositional logic with first-order logic. Propositional logic deals with propositions as atomic units of truth. For example, if P stands for it is raining, and Q stands for streets are wet, then P implies Q can be written as P implies Q. On the other hand, first-order logic includes predicates, variables, and quantifiers, allowing for more complex statements. For example, we can express for all x if x is human, then x is mortal, written as for all x human x implies mortal x. Given that Socrates is human, we can conclude therefore Socrates is mortal. Let's delve into the syntax of first-order logic. The components include universal quantifier denoted by the symbol for all. The existential quantifier is denoted by the symbol there exists. Predicates are denoted as P of x, which express properties of objects. Variables are represented as x, y, and constants are represented as b. Now let's look at the basic structure. A term can be a variable, a constant, or a function. An atom is a predicate applied to terms. A formula can be an atom, a negation of a formula, a conjunction of formulas, or a quantified formula using for all x, or there exists x. Now let's discuss first-order logic semantics. Interpretation denoted as capital J involves a domain capital D, which is a non-empty set of objects. Constants map to elements in capital D. Predicates map to relations over capital D. Functions map to functions from capital D to capital D. Here's an example. Suppose capital D equals the set containing Alice, Bob, Carol. And friend of x, y is the relation containing Alice, Bob, and Bob, Carol. Then, for all x there exists y friend of x, y is false because Alice is not friends with everyone. Similarly, there exists x for all y friend of x, y is false because there is no one who is friends with everyone. So, what is decidability? A problem is decidable if there exists an algorithm that always terminates and correctly determines yes or a no. In formal terms, there exists an algorithm capital A such that for all input x, capital A of x halts and gives the correct answer. For example, sorting algorithms in prime number testing are decidable. However, the halting problem and first-order logic theorem proving are undecidable. Let's explore the halting problem. The problem statement is as follows. Given a program capital P and input x, determine if capital P of x will halt or run forever. Consider the code. Def halts of program input. This returns true if program of input halts and returns false if it runs forever. The question is, can such a function exist? Let's prove by contradiction that such a function cannot exist. Assume the halts function exists. Construct a program called paradox of capital P. If halts of capital P loops forever. If not, halts of capital P return. What about paradox of paradox? Let's discuss computational logic. By definition, it is the study of algorithmic methods for reasoning about logical systems and implementing logical inference in computational systems. It has several key applications. These include automated theorem proving, logic programming like Prolog, model checking, and SAT solving. Now let's explore the SAT problem and the resolution method. The SAT problem is defined as follows. Given a Boolean formula in conjunctive normal form, determine if there exists an assignment that makes it true. For example, we have P or Q or not R, and not P or R, and not Q or not R, and P or Q. To solve the SAT problem, we can use the resolution method. First, convert the formula to conjunctive normal form. Second, apply the resolution rule, where A or B, not A or C, gives us B or C. Third, derive new clauses. Fourth, if an empty clause is derived, the formula is unsat. Fifth, otherwise, the formula is SAT. Let's summarize the key concepts. First-order logic extends propositional logic. Decidability determines algorithmic solvability. Computational logic bridges theory and practice. SAT solving is fundamental to many applications. Logic provides formal foundations. Decidability sets computational limits. Algorithms make logic practical. Together, they form the basis of automated reasoning. Thank you for watching Logic and Computation Foundation of Computer Science. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.